is Justin.
Okay, if you could get out some sort of festive pen.
What?
A festive pen so you can mark your quiz.
I don't know the festive pen.
I know.
Oh, this is like really one of the ones that does not matter.
Always matters.
But like these
Always
ones
matters.
really aren't counted.
Always matters.
They're not counted. So.
Okay.
Wait, I'm cooking on this question. Shut up.
It would be useful.
See, you're a hater. What? You're a hater. I don't want to hear it. Wait, look.
First one. Why are B and C impossible to be the answer?
Because we don't know because they're soluble.
Yeah. How do we know B and C are soluble? You almost don't even have to look it up. Which ion in B and C screams soluble?
Nitrate.
Nitrate. If you look at the nitrate, let's zoom entire page. Nitrate, soluble with everything. Sodium is probably the most common alkali ion you'll do, and it's soluble with everything. So as you're looking through, Pete, whenever you see a sodium, you know that's going to dissolve. Whenever you see a nitrate, you know it's going to be dissolve. The only tricky one was really iron 2 sulfate. Go down to sulfate, and iron 2 is not one of these, so it would also be soluble. And so the only one left is barium carbonate. Go down to carbonate. Where's carbonate? There it is. And unless you're one of the things that's soluble with everything, carbonates form precipitates all the time. And so it has to be A. So the only tricky one was really the iron sulfate that you would have had to look up. Question number 2. What is wrong with the other 3?
The first one doesn't even have the right one.
Doesn't even have the right what?
Like, it doesn't have the right, like, formula on the
Yeah.
product side.
That one's very weird.
And then the second one, you can't, like, make a saturated solution if it, like, stays together.
Well, what do you need? What did the second one?
It needs, like, dilution
Dilution?
or, like, the right separation.
Yeah, you need it to disassociate. It doesn't put it into ions. It's kind of treating it like some sort of molecular compound in which it doesn't actually separate. And what does C do to it?
Separates
The polyatomic that doesn't separate, they separate it out. So D is the best answer.
You were gonna hate too.
Question number 3. D looks a little tricky. Rb2s. You probably haven't seen rubidium that often. Rubidium is one of your alkali ions, so it's soluble with everything. 4. What could you do? Why would magnesium sulfate work?
because it's not gonna, like, precipitate.
So magnesium sulfate, is it soluble or low solubility? If I ask if it's soluble or low solubility, and you're not checking your solubility table, your solubility table is going to tell you you've got magnesium, you've got calcium. If we go to the actual quiz, where was it there? Calcium is there. Magnesium is not. Oops, that one. And so if we add some calcium sulfate, why won't that work?
Because it will increase it off into the right.
This is a very good question. It will not shift the reaction to the right.
Why?
B, could you move over one, please? If you add calcium sulfate, why doesn't it shift it to the right? Well, magnesium sulfate works because
Oh,
it
wait.
separates, and you get sulfate, shifts it to the left. But what's wrong with adding calcium sulfate? It would work in almost every other equilibrium. It has to do with its state. It is a solid. I wouldn't know about solids and KQs.
Oh, they don't shift. They
They-
don't make anything.
They don't make anything happen. If you add more
Oh, I see, I
solid
see.
calcium sulfate, it doesn't change the concentration. You change the
Oh.
amount, but the concentration stays the same. So adding it actually doesn't do anything to the equilibrium. And that should make some intuitive sense if you have a saturated solution. Does adding more of the solid make it more concentrated once it's saturated? No, so it doesn't shift it. Once it's saturated, it's saturated. This is just a really fancy way of seeing what precipitates. A precipitate forms with 0.2 molar, and again, the 0.2 is just to make sure it doesn't drop below 0.1, so you can claim that everything might dissolve. Containing an unknown cation is added to sulfate, but not when an equal volume is added to sulfide. So the question is, which one of these precipitates with sulfate, but not sulfide? Yeah, I was looking for this. Sulfate, sulfide, and yeah, calcium. Soluble and low solubility right
It wasn't.
there. B. Equal volumes of lead nitrate and potassium chloride is added. It tells you which the precipitate is. Go there. What is the you?
No, they're wrong.
Evan, what are you arguing about?
If it's in,
Marcus got it.
bro, I didn't.
See,
If
no
it's in
bracket.
brackets,
No
it's-
bracket.
dude, the bracket's not gonna make it wrong.
Let me see.
The brackets
The
make it
bracket's
wrong.
not gonna make it wrong.
Yeah, that's right.
That's right.
Wrong.
What? Why?
Um,
What? I can't put bracket. If the brackets actually. Bro, are you kidding me right now? Is it the brackets? No, bro, that's not fair. That's not fair.
Just so that nobody does that, why is that wrong?
That's not fair.
Actually,
How many of those do you have?
one.
One. Do we ever write the one?
No.
If you don't write the one, do you need the brackets?
No, but like,
But it,
why would you mark off?
If you're writing a paragraph,
No, I know.
no, and you put a period at the end, and then you start the next word the, you don't capitalize it, you put a period in, you don't need it. You don't need a capital to tell you the beginning of the sentence. It's just a rule in English. The rule of naming is if you don't need the brackets, don't
Yeah,
have them.
bro, are you marking me off for that? Or?
No, I'm saying IUPAC is marking you off from that. You just gave it the wrong name. This implies that you forgot a number, and that would be wrong.
I didn't forget.
It's not completely wrong, but it's wrong.
It doesn't change it. If you had 3 and then 3 in brackets, it's 3 no matter what.
Yeah, I'm not saying that these show a different number.
They're showing the same thing,
Yeah,
but it can be wrong.
of course it could be wrong.
That's dumb.
Yeah. If you wrote down this, why is that wrong?
Well, that's like a given. That's completely different.
But do you know what it means?
Yeah.
Yeah, and you're not really going to think that's Nobelium or anything. The IUPAC, it's the IUPAC rules. To make for sure for clear communication. If you see brackets, you know it's not supposed to be a 1 there. So that means that you have a Richburg, it's a different compound. Maybe it's some weird potassium plus a half, which, not plus a half, plus 2, which could exist. Is it far enough down on the table? It might be. All I'm saying is if you do that, that is an incredibly bad habit. If it's a 1 there, you don't need the brackets. You haven't gotten anything logically wrong. You've gotten things communication wrong. Okay, next one, balancing. You do need a 2 in the KNO3 and the 2 in the KCL. And one of the reasons is, again, to carry it through. Whoops. I think I just messed that up. 2 KCL. Where'd my KCL go? There it goes. There it goes. And then the 2 from there goes to there. So when you're going through the complete ionic, carry through the balancing. If you have a 2 outside the brackets, that would go down. 2 outside there, they both have 2 because that carries through. That one doesn't separate because it's a solid. The 2 would carry through to both of those. Cross out was the same on both sides. PB plus 2 plus 2CL minus goes to PBCL2. Was the bracket the only thing you got wrong?
Yes.
Take off minus a half.
Are you kidding me right now?
You're taking it off in your own quiz that you get to keep. I want it to hurt deep inside so you never do it again. Who taught you Science 10?
Miss Lawrence.
Okay. I want you to go after this immediately go yell at her because clearly she didn't drill that deep inside you where it hurts. Where's the actual notes? Oh, there it is. Okay. Pull out your notes. Predict the 2 products of those reactions. Identify the precipitate. I am going to quickly take attendance. Carrots, gold, Elena's, oops. Elena's not here, Evan's here, Hannah's here. Henry's not here, Henry's not here. Isabel's not here, Marcus is here, Matt's here, May's here, Naomi's here. Nicholas? Naomi's not here. Nicholas, Portia, and
So late, what? How do you know? I don't yet.
okay, Portia. Give me one of the products.
Oh, let me flip to my page. AgCl.
Nice. NO. Excellent. Cole, which one's the solid and which one's the aqueous?
Cold in the washer.
That's terrible. Matt, which one's the solid, which one's the aqueous?
Oh, I found.
Hold on,
You find out.
my chart away.
You need your chart, yeah.
I know. I gotta regrab it. Give me like a couple seconds. I'll
Porsche had you too.
Don't worry, I'll get it.
We'll get Cole to do the next one.
Also, you can just look at the chart and then see that
It's the NA
Silva
NO3.
is not gonna be
It's
solid.
sorry. It's the non. It's not this.
Not DNA NO3, yeah.
That one's soluble.
That one's like double soluble. Excellent. So what does it have to be? Which one has to be the solid?
It has to be AgCl.
Right. And did you look up and see that it was AgCl?
Well, I just immediately checked one of them, and that one wasn't the precipitate. So out of two things, if one's not, the other has to be.
That's probably pretty reasonable. There are cases sometimes where you could get both. Not both will be the precipitate, but both aqueous. So do watch out for those. Cole, what are the two products of the next one?
Wait, is that KL or KI?
Oh yeah, I hate sans serif font.
Yeah,
Yeah,
Is it I?
it's I.
it's an I. It has to be an I.
That makes more sense. Shut up, Marcus. Shut up.
I gotta convert everything. Oops. Oops.
Dubai font? Why are there so many fonts? Whoever uses them.
If I'm very good.
There, that makes it a little easier. One of the reasons Comic Sans was invented is because you'll notice there's little asymmetries everywhere. That helps if you have forms of reading dyslexia or anything. It makes it really clear what letter it is. As opposed to a sans serif font, I don't know if I'm pronouncing that correctly, in which they get rid of all these little curly cues. Those are serifs. And those help tell what it is. So you can tell the I from the L. And so much of the world now prints everything in ways that make that harder and harder to tell. The default fonts usually don't have them. Okay, go.
PBI plus AM.
PBI
PBI 2 now.
plus K. Well, I'm going to let
I see.
Cole tell me. PBI, PBI2, PB2I, PBI3.
PBI 2.
Well, how do you know?
The charges or something.
Yeah, because the charges are something.
Yeah, because the charges.
It was the R something that got me. How do you know that lead is +2 from this one?
Because it's after them.
Yeah. Uncrisscross if needed, +2. This is a 1, so put that there. That's -1. Is nitrate -1?
Yeah.
Yeah, so that's correct. So the lead must be +2. Iodine's -1. That works out well. Probably need to balance. And there we go. Next one, create two reactions in which the reactants will both not create a precipitate, but each one will. Let's do that one on the board so we can see them. You are not allowed to use a reaction that somebody else has used. So once you've claimed a compound, the first person to write it gets it. If you're in there.
I have no idea.
Write equations. It's a fun day to write equations. Most of you are in great sweaters. Mia said I don't have Christmas spirit. So I'm going to try and prove Mia wrong by writing equations for you.
I didn't even check one.
Reactions are both not.
I know. I reread what I wrote, and like even I had trouble saying it. Your reactants shouldn't be precipitates. Only one of the products should be.
So it's like just like the question that.
So just like the previous two examples, and you can't use the previous two examples. Teachers hate it when students use their own examples for their things. Mr. Collis had the great minds write an essay on the three favorite things. And he gave them the example of his three favorite types of passing. Guess what half the class wrote about? The three soluble.
But one of the.
But when you mix and match them for the product, one of them shows. Let me take a look, sorry. Oh, that's. Silver hydroxide. That's
One of the products.
I just think outside the box.
yeah. Now, do I see you done with it? I think silver hydroxide might precipitate.
Oh, thank you.
So, silver hydroxide, hydroxide, those are
Right, alright.
no silver. Silver hydroxide. Well, on that side, both
Here,
have
Fred.
more silver.
Because
Clever, very clever.
Yeah, they're both solid.
Because that was basically one of the reactions.
So we can't do any
Like,
I actually didn't look at
No.
it. I was just looking at my thing.
and this is actually a famous reaction too. Yeah. Who takes photography?
Oh, I did.
Black and white photography? Did you ever do film development? What did you use to develop the film?
it's they call it development. Yeah.
Oh, they don't call it silver nitrate? You're literally precipitating black silver. Yeah.
Black silver.
Well, the
So
silver
it's
is
not
black.
silver.
Well, it looks black when it precipitates, yeah.
I didn't
The
look at
silver chloride.
I didn't
Silver's
look
a
at
color.
The pure metal, yeah.
Realistically, silver.
But
When you think of colors, it's all
But if I say silver chloride, it could be any color.
I'm thinking of a chloride.
Well, specifically.
Just so happens to be the color.
Nice, okay. You have to do two of those. Create two reactions.
That's the same.
But nitrate and spa, metals get written first. BAS, yeah. And let me just check. Sulfides are weird, so I'm highly suspicious that the barium sulfide might be a precipitate, but it might not be. Is it soluble? No, it might be. So, yeah, it is. Good choice. It makes lead sulfide. Nice. Precipitate. And very nitrate. That's a good one. Excellent. Yeah. Next one. You have to do it again. You can't have any of those compounds. So you can't have the exact same reaction. But you could use an individual compound. Now I can finally. Okay, what do you got?
I don't think we make it balance.
Now, ironically, for this one, you get half mark up because you didn't correct. Very fake. They're there. Okay. What charges on the iron? What charges on the iron on that side? Oh yeah, I can do that. Okay, that's why I made it. That is why we want to balance.
Wait, because the max is good.
Now you can balance.
Is this like right though?
KNO3 and FeOH2, OH, that is low solubility. That You just made an acid-base reaction in which one of them does in fact precipitate. That would qualify.
Not like you did.
Because an acid-base reaction is did you make sulfate? Calcium sulfate? Then we got the sulfite, we got calcium, soluble, magnesium sulfate, sulfate with magnesium sulfate, calcium sulfate, definitely.
I can tell.
Magnesium soluble.
Soluble and not precipitate.
It's soluble, perfect. Let's do it. Your hydroxide is going to be low solubility. Oh no, it's not. That works. Okay. KNO3, strontium hydroxide makes hold it. Everything soluble in your equation.
Why is it soluble down?
Hydroxide?
I was listening, but. Hydroxide, all others low solubility.
Yeah, but K plus is insoluble.
What?
Yeah, you're,
No, it's not.
yes it is. I'll bet you. I'll bet you.
Wait, what are
Like
you?
your sweater.
Where are you looking?
Okay, so there, hydroxide, and then I see potassium insoluble. I want you to stare at it until you see it. Is it that one? Is it that one? Is it that one? Wait, no, keep looking. Is it that one?
Open my phone and Instagram was on.
No.
Nice work, Echo.
Let's change this.
Yeah,
So there's not an alkaline out.
yeah,
Like radiant.
like almost anything, yeah. This group's got two, this group's got two. You guys know what? You are, I've checked your first one. Bromine. You've got barium and bromide. Is that barium? That's low solubility. Bromide. Low solubility. Oh, hold it. It's soluble. Never mind, I read it wrong. That's mine. Copper sulfate? Sulfate? Copper. Copper soluble. Goes to copper bromide. You change the charge right here. Nope, perfect. And bromide is low soluble. And then barium sulfate is also low soluble. These are both solids.
Why is my phone so slow?
This was very careful. I would guess that those were
Boom. I don't know the charges again.
You can just give them charges. It's a merit. It's a merit theory. You can just give it like just make its charge consistent. Like as written, you have it as +1. Yeah. Yeah. So americanium nitrate and francium hydroxide goes to that hydroxide would definitely be precipitate, and francium nitrate. That's the most expensive reaction in the world. Not only do you have americanium, you also have francium, which is radioactive and only exists for 20 minutes. So to buy it, you have to have a whole particle accelerator. Yeah, that works.
What's American?
I don't even know. I use it so little, I don't even know how to pronounce it. Americium. It just seems wrong. Americium. Americium.
What is it?
Americium. That sounds better. You gotta put the stress on where the Americans put the stress.
Oh yeah, 'cause this is
Americium. No. Magnesium sulfide. So that's sulfide with magnesium and it's soluble. With strontium hydroxide. And so that strontium hydroxide works.
Marcus, what was your cost
The
yesterday?
magnesium hydroxide
What was your
is
cost
going to be.
yesterday?
No.
Aria?
Is it?
What was that?
Yeah. Oh, okay. And then
She said
strontium
we're almost there. 250 off the line.
sulfide is in fact soluble. Yeah, that works.
Gotta love Nas.
Beryllium sulfite.
Gotta love
You
Nas.
mean SO4? No, SO3. So that is a
I think we should be allowed to.
Oh, yeah, it is. Wait.
Relax.
I did like 3 units of Hebden last night.
We sat down for like 3 hours in the common room
Oh,
with our Hebden books open. I got one question. Like one part. I did one A.
Going for that one. That's going to be probably.
I had a class last night, so I never got back to my class. Sat down,
Oh,
and
those
it
are
was
all-
just there until midnight.
And then EK.
And
We
then
were
I
in the
had
common room till like 1 a.m.
And then
and I had
KM.
to do AP Calc until 1
Well,
a.m.
maybe fuck you. You can count that now.
And it did.
What's your grade? What is-
It's a C.
Whoa.
Yeah, you're telling me.
That's bad.
But
Come back with this.
I did all of this last night.
That is soluble with everything.
And
But that is also soluble. You want a pair that's going to come together to be soluble. You took your
Smith's
beryllium
class is actually really kind of chill. But
so that
I don't know. He had a hard test.
Smith's classes are two of the worst that I can't understand.
Yeah, that's fine.
then
That's
you
last year.
two soluble things come together into a non or at least one non-soluble.
I have no idea if he likes me, to be honest. Like, I think he low-key does.
I'm not sure yet. I don't know what age it is. Ask my parents for this first and
Okay,
Nice.
a hint for doing that. This is a fairly good, well, I don't know if it's a good hint, but whenever you're looking at a test or a question, when someone has to make up a series in which you only get one precipitate, there's a whole bunch of things that are soluble with everything. One of those is the alkali ions. One of those is ammonium, but you'll almost never see ammonium being used because it's an acid, so we're not going to want to use it. And then what's the negative one that's soluble with everything? What is the negative ion that's soluble with pretty much everything? Pardon? NO3. Find one compound that is low solubility. Any compound. No, compound. Two together. Silver chloride. So if you find one thing that's a solid, now just pair it with the things that make the different parts soluble. So for the negative, we would go AgNO3 plus, say, LiCl. That'll make lithium nitrate, which will obviously be soluble, and then silver chloride. Any other compound that's a precipitate? A weird one. Americanium what? OH, there. You've made ammo. This is clearly +1 because hydroxide is -1, so we would make it Am with our negative, NO3, plus, let's pick potassium this time, KOH. Those have to be soluble because nitrate and potassium are always soluble because it's an alkali metal and nitrate. And then it will make our mercurium hydroxide and potassium nitrate. So whenever you see an alkali metal and nitrate, you know that you have a pairing that's going to make a precipitate. It's going to be the other one. Write a formula equation, complete ionic equation, and net ionic equation that represents a precipitation reaction. Iron 2 sulfate reacts with ammonium sulfide to produce a precipitate and a soluble salt. All reactants are aqueous. Write the formula equation as well as the complete and net ionic equations. Find your new people. Go write them to the board. Do that on the board. Because then Evan will finally put down his phone. Evan, what are you doing on your phone? It actually looked like you had your calculator.
Yeah, it wasn't like this.
Oh, yeah, I'll put it back up. Everybody have their partner? There you go. 2 sulfate. Ammonium is NH4. Yep. But then again, I shouldn't tell you. I should make you look it up in your data table. So you get used to your data table.
We were there for one and a half, one and a half hours now. Sulfate was not high, it's like were you like okay put it turned off? This is so scary. I thought I was gonna die. Okay, perfect. You stop.
Well done, Evan. Well done. Moving things on.
Okay.
Here, Portia. There's room here.
Yeah, that's.
Like it wasn't on, but it was like beeping, and I thought, oh,
As a reminder, positive ions are always written first. Marcus and Declan, positive ions are always written first. Cool? Positive ions are always written first.
Oh, this one's. What did you do? What is this? God,
Portia, what just happened?
nothing.
Straight up.
Okay.
She did nothing. It'll have time to dry before a long break. I feel like that's a pretty long time.
Where are you getting your reaction from?
Look. I mean, so we're reading a different question.
Fair enough.
Oh, you're right. And then, is it
That's one. So that's just all the APs.
We know that one.
Plus one.
Hold on, you can't listen to you guys.
That's minus two. That's also minus two.
And then we can, yeah, so that's back. C's plus.
What does it mean it makes there's no sodium? Is it H2O? Repeat it back.
Class A is for one.
Yeah.
Wait, SO4 is minus, right?
Ooh, I like your. Positive ions are always written first, which will affect your very first one. Yeah. Other than that, because you did everything else correctly, it's not gonna matter. Okay, you just fix that
No,
one.
no, this is good. No, this is good.
But because you have the right amount of ammonium and stuff,
Yeah.
and then you balance out to that correctly. Not gonna
Oh. I keep reading the
Which one's number?
in the
PB,
middle
that
of
one's
class.
PB, so it's still.
Little.
That's a good solid. That's a good solid.
Yeah, that's what I'm
PB,
good.
SO4.
Yeah.
Because this is
Wait,
PB is 2 as well. PB is 2 as well.
Okay, we'll just do that.
We can't figure it out.
I think
Just trying to make it,
it's the same one.
get him to make a normal thing that works. There's one given. It
Bro, but
Yeah, it's example one.
says write a formula at the start.
Yeah. Iron 2 sulfite reacts with ammonium sulfide.
We've been trying to create one.
I'm
So difficult.
I'm so impressed. So impressed with trying to create. But you don't have to. You could do that one.
That makes it so much easier. And ammonium sulfide. SO4.
We should have done better.
Come on now.
Okay, so for instance, it goes to FBS and H2SO4. Excellent. Need any balancing? No. Yes. Your second one needs balancing. I think you're just missing it. You might be missing the 2 on your ammonium.
I don't know.
On the left. But you do have it on your right. So there you go. Yeah.
Bracket NH4, bracket 0.
No.
No.
No, here, I'll do it.
No, it's okay. Bro, we did.
There's a model
Awesome.
What was
of
your last? You don't know what your last time was?
either a crystal,
It's so long.
a particular wax.
This one was so fast. Oh, wait, I like this was better.
I think it's missing a few.
Pretty wild. Should be up here.
There's a bunch of them there.
Yeah.
Oh, yeah. So it's just
There we go. Oh, yeah, at the end. Someone said we don't feel like balancing.
Who was that?
Who was that? You just, this is balance.
Oh,
And so all you do is you take that 2, you put it there.
right.
And you take that 2, and you put it there.
Okay.
What's the charge on ammonium?
It's probably wrong.
Just plus. And sulfur is minus 2. Hold it, that's a K, right? Nope, That's fine. That's good. Rest of that's good.
Get it out, get it out.
Get it out anywhere.
Take your time.
Mm. Oh, at the bottom, we actually have to write some notes.
I think looking on that line, I think your best time was like 7 seconds. 9, 8. I agree, get it down. Yeah. 3, 2, okay. Dude, you can't restart. Dude, you have to get everything like in, hitting in correctly. Russ doesn't work. Hit it.
Okay, what's the definition of a spectator eye?
Spectates.
It doesn't do anything. Is a good practical, like you don't see it becoming something else. But how can we define it so that we know exactly what it is?
What?
How do you know in your complete ionic equation
It's the
that it's a spectator eye?
It's the same reactance and product.
It's the same in the reactants and products. An ion that exists in both reactants and products. Because it's an ion on both sides, we can cancel it out. If it became a solid, it wouldn't be an ion anymore. Let's take your new partners to the board. Bring your data booklet.
What are they?
Take your partners to the board. Get your partners. There. Out of the way.
How's your morning going?
Okay. Using your newfound knowledge of precipitation, you have a beaker. It has barium in it, and it has lead in it. You would like it not to have lead in it. I want you to separate out the barium from the lead. There's tons of data tables right in the front there. Grab them. There are. You do feel it now. Sorry.
SO4 2 minus. SO4?
What?
That makes it barium salt.
Does it?
Yeah,
What, does it only precipitate one of them?
Oh, wait. Mix barium salt. Barium or mix barium. Oh, it takes a couple days for each one?
Oh yeah, go ahead.
What's lead salt? Just a separate. Oh yeah, wait, yeah. Make lead salt. Wait, do we have to precipitate BR?
Eventually you want to precipitate both of them, but you want to precipitate them separately.
Yeah.
Yeah.
Okay, so you can go. Wait, so you start.
Declan?
Are you part of the solution?
So you start off with like BA,
Declan?
PB, or no?
Barium and lead are the same. They're both metals.
What? Oh,
You can't put them together.
Yeah, we can do this one. BA,
your BAPB?
Bro, why do you want our board?
Or is that me? BAP, they're both metals, they won't join up.
What's gonna go with what?
So you want like
It's not good.
The one that goes with the barium has.
You don't have to write it as one equation, you can write it as more than one. First add what? NaCl, and what will that precipitate? Will it precipitate the barium? Barium. Yeah, well,
and then some
ECl,
Wait, but if it's
and then, you make barium sulfate, and
One
one
of
goes
them
to that one.
then does
Yeah.
it matter?
And it goes to ER.
Mhm.
If one of them's already precipitated.
Why do, okay, stop. Stop. Multiple people keep writing down BAPB, and I wanna know why you're doing
Oh
that.
yeah, that's not because their brains are broken.
But you're all doing it.
What else could be in the thing?
No,
That just makes sense.
stop that. That makes sense. I'll take you like I took out glass. Okay, look this way. Because these both exist in a solution, but that doesn't mean they're a compound. You can't write down that because they're both positives. What do positives do? They go apart. So there's probably also nitrates or something in there. We don't know how they were added. There's negative ions. We just don't know what they are. So you don't want to put them together. You want to add them to something that's going to make it precipitate. So if it makes you feel better, you could make it a nitrate. But it's just Ba plus 2 plus something. We have one so far that works. So erase your BAPB, because it is the really spicy peanut butter.
So if you precipitate this out, and then you use SO4, which will precipitate, it will precipitate this, but this is already precipitated, so it doesn't matter.
Yeah, it doesn't matter at that point.
So
Yeah,
then you-
yeah. Just make sure you put it in all your charges. You're good to go. Oh, don't put it upside down. I am worried eventually the pressure would start to leak.
Wait, what's in there?
Silver.
Actual
Is there
silver.
anything that causes to die?
It should be acidic. Yeah. But it used to coat the flask. It was like a silver flask because it coated on the inside. And then slowly over time it just sort of came off and just made a nice glistening little toxic Christmas bulb. Does iodine only precipitate the PBs?
Yeah?
Then you're good. Yeah.
Yes.
So what is something that some people added? B, can you put your phone away? Like away. It's the last day. I don't want to make everybody put it in the box.
There's like a minute left in class.
That's okay. What is one of the things that precipitated only one of them? Iodine? So we added as what? If you have iodine, what are we going to add it as? Like if I go get it off the shelf, I don't have iodine, but I have.
Wait, do we have to
KI.
put it in the chart, or like if we can just do it in our head?
Yes.
This is just. Are you talking about this?
Yeah.
This is a handy way just to help figure it out, I find. Because if I add Ki, what's my precipitate? PBI? PBI2 solid. And for this one, barium iodide is soluble.
Yeah.
Then you can just put down soluble. You don't have to worry about it. And then for the second one, you can add anything that would precipitate what's left. What will precipitate barium? Pardon? SO4. So say K2SO4.
Yeah.
So you do have to put on a positive ion because you have to get it off the shelf. It's going to exist as a whole compound. But then you get BaSO4. And that one doesn't matter because you've already done it. and then you have to write up a procedure, which I accidentally left the old one on. So in this case, we add Ki until no more precipitate is formed, filter off the PBI2, and set aside. You could take your Hebdens and put them here.
Yeah, not hanging out.
If you really, really, really believe that you're going to do Hebden over Christmas or holiday break, you can keep it.
I'm gonna do
In
that.
my experience, everybody who thinks they're going to do that actually ends up not.
Newf, I'm gonna do that.
These are lies.
I'm gonna do it. Why do you think I'm kept that?
Hand in your Hebden. If you don't, if you're going to do it, if you really, really, really think that you aren't, you're going to do it, just bring it up to me and I'll sign the last page so that I have an opportunity when you come back to say I told you so when you don't do it.
Mine's not done. I'm gonna do it.
Okay. Yeah.
I don't have it on
Well, go get it.
right now.
Yeah.
Bring it back.
Yeah.
So much effort.
Yeah, well, that's what you bring before you came, so we can do that. Hold it. Are you taking it away or just handing it in? Okay, perfect. Sorry. Oh, what happened to your Hebden book?
Cap.
Oh, you had it now? Oh, put this in.
Oh, so what, I was gonna actually take this from all the time.
I'll give it back.
What if I told you that me and I stayed up till 1:30?
I would be really impressed.
Yeah, what if
Newf,
I
me
said
and-
that?
me and Marcus were up till 1 as well.
I'm hoping the lesson is that you do a little bit at a time.
What if I told you that me and Evan stayed up till 1
The lesson is that we
a.m.
literally have 3 days left to test on every single
That's
day.
my other
Where is it?
They would not believe it.
Haley and I are waiting for.
Newf, me and Marcus were up till 1 as well.
Are you really gonna do it over Christmas?
I did it over Christmas last Christmas.
Okay.
Will it, will I have my
No, just show it to me after Christmas. I decided it. It's fine.
Or, what if I didn't finish it?
Are you good? You want it back? Are you really gonna do it over Christmas? You're not gonna enjoy yourself at all? Just sadly do chemistry. I expect you to be doing chemistry then at Christmas week. Oh, that's good.
Kaylee and Myra are waiting.
Are you taking it away? Or are you taking it? Don't do too much.
We don't have to do.
You don't have to what?
We don't have our money.
Melanie, she don't have to do
We're so
I said, well, what if I
happy.
told you that me and Evan stayed up till 1 a.m.
They
I
were.
was there.
Yeah.
The power went out.
We're working somewhere.
Yeah, you were. Well, it's one of those like good because you realize you have to do that, but it's also like you have to keep up with a little bit every day.
Does it not show our dedication though?
It does, and shows
I got so much effort.
that you didn't care about it earlier.
Well, yeah.
Yeah.
I got so much effort.
You're welcome.
And now I'm gonna do it over break. Oh, yeah, break. Actually, I'll see you. Yeah, dude, I'll see you like literally.
I'm also excited because I was the person for years I would bring my university homework with me to like trips and visit family. You never do as much as you think you're gonna.
Yeah, exactly.
Sorry?
The smart boards.
Oh, no worries. The smart boards. They're very smart.
Whatever they're called.
Yeah, because there's almost no processing lag. They're so good.
Thank you.
No worries.